Okay guys, so ito na yung ating lesson 11 sa ating Advanced Calculus 1. So ito yung limit of a sequence or sequences. Okay, so what is a sequence? A sequence is a function whose domain is a set of the form and element ng integers and is greater than equal to I. Usually I is 1 or 0. So may nakikita kami sa na sequence nag-i-start sa 0 term. So kung na A sub 0, may nakikita ka usually na sequence A sub 1 or S sub 1. So S sub 1, S sub 0. So yun yung mga usually na nag-i-start yung ating sequence. So ito yung mga notation ng ating sequence. So notation, S sub n for n is equal to n, m up to infinity is equal to the sequence S sub m plus 1, S sub m plus 2, and that and so forth. Okay, so ayun yung mga first term, second term, third term ng ating sequence. Then if m is equal to 1, then ito yung mangyayari, n element lang ng natural number. Bakit? Kasi ang mangyayari, yung n is equal to 1 up to infinity lang. So more precisely, gawin na natin n element ng natural number. Okay, so ina-assume nila na infinity yung above nung natural number. So parang i-assume lang natin na tuloy-tuloy siyang umaangat, pero never yan mga magiging decimal. Okay, so baka maging contradiction dun sa dating sinabi ko na yung dulo ng natural number is not infinity. Okay, so ginagamit nila infinity dito para ma-assume na tuloy-tuloy yan na umaangat. So nag-i-induct yan tuloy-tuloy. So sana clear tayo about dun sa sinabi ko na yun. Ayun, let's have example bago tayo mag-start dun sa mga proving about dito. Okay, so example muna tayo. So number 1, A sub n is defined to be 1. So ano yung mga laman ng sequence na to? Yung sequence na to, so ito yung A sub n. A sub n is equal to A sub 1, A sub 2, A sub 3, A sub 4, and something. Okay, ganun kasi talaga lalagay. Ngayon, kung papalitan natin ng mga 1, A sub 1, A sub 2, A sub 3, A sub 4, that is equal sa, kung papansin, 1, 1, 1, 1, and so forth. So, tuloy-tuloy lang siya na 1. So, yan yung sequence na ang tinatawag is constant. Okay, so ang tawag dyan constant sequence. So, tandaan na, ang tawag sa mga ganyan sequence, na kung saan ang term lang niya is a constant, is constant sequence. Okay, so next is yung S sub n. S sub n is defined to be 1 over n squared. So, paano yung 1 over n squared na yan? So, ito na yung write ko na lang ha. So, 1 over n squared. Okay, so ngayon mag-i-start ako sa 0. So, para mas maano tayo. So, for n is equal to 0 up to infinity, ganun yung gawin natin. So, dito lagay ko lang, for n is equal to 0 up to infinity. This is equal sa, check nyo. If n is equal to 0, that is undefined. Okay? So, kung napansin nyo lang, if n is equal to 0, that is undefined. So, meaning, hindi natin pwedeng gamitin yung n is equal to 0. So, meaning, yung sequence na ito, mag-i-start sa 1. Okay? So, that is n is equal to 1 up to infinity. So, for n is equal to 1, that is 1. For n is equal to 2, that is 1 over 4. 1 over 9. 1 over 16. 1 over 25. Then, and so forth and so forth and so on. Okay, so ganyan lang maglagay. So sa akin, kung maglalagay ka ng mga term ng sequence, kung gusto kong ipa-evaluate yung laman niya, gusto ko 5 terms. Okay, so kunwari A sub 1, A sub C, A sub 2, A sub 3, A sub 4, A sub 5. Ganun yung gusto kong gagawin niya. Okay, so A sub 1 dito, yung S sub 1 dito is, ano yung S sub 1? Lagay ko na lang, S sub 1 is 1, S sub 2 is 1/4. What is S sub 7? Sir, S sub 7 is 1 over 49. Okay, so kunyari pinahanap ko sa yung mga specific term doon, ganyan din yung gagawin mo. Okay, next number 3. So, let A sub n be defined to be the sequence of n and root of n. So, ano naman yung mga laman ng term natin dyan? So, syempre dahil n root, wala naman 0 index. Tapos kung napansin mo, meron bang 1 na index? Yes, pwede tayo dito mag-start. So, kung 1 yan, that is only 1. Hindi siya 1 to root of 1. Walang ganun. So, ito lagay ko lang ha. So, this is A sub n. Lagay ko na A sub n. So, whether kahit ano ilagay mo, whether yung mismo loob ilagay ko or yung A sub n lang, okay lang. Okay, so, this is equal sa, so, una, for 1. So, this is 1 lang. Kasi, n or 1 raised to 1 over 1 is 1. Kasi pwede kong gawing n raised to 1 over n yun eh. Tama? So, 1 raised to 1 over 1 is just 1. So, next is for n is equal to 2. That is square root of 2. Next is cube root of 3. Next is ay fourth root of 4. We have fifth root of 5. And that something. Okay, so ganyan siya kasimple. So alam ko ito yung sequence ng irrational kasi pagkakaalala ko nth root of n is irrational. For n is greater than or equal to 2. So alam ko ito yung sequence ng irrational. So kung tatanungin mo ako kung maghahanap ka ng sequence ng irrational, ito pwede mo example. Okay, so hindi ako ganoon kasigurado actually. Okay, so number 4. If we have b sub n is defined to be negative 1 raised to n. So kung napapansin mo, ano yung mga values niyan? So dito pwede ka mag-start sa 0. Tama? So pwede ako mag-start dito ng, so lagay ko rin sequence. Assuming lagay ko dito, ito yung negative 1 raised to n. For n is equal to 0 up to infinity. So pwede kong gawin yan dyan kasi walang mangyayaring epekto. So ngayon sir, kailan kami magde-decide kung pwedeng 1, pwedeng 0? So, minsan ako naman naglalagay ko sa nag-i-start. Pero kunyari, ganyan ang binigay ko. So, ikaw na mag-decide minsan kung pwede ba pag-start sa 0, pwede ba mag-start sa 1 or what. Okay, so, ito ay starting sa for n is equal to 0, that is negative 1 raised to 0, which is 1. Okay, for n is equal to 1, that is negative 1. And kung napapansin mo, 1, negative 1, 1, something. So, mapansin mo, alternating yung kanyang sign. So, ang tawag sa ito is oscillating sequence, pagkakaalala ko. Oscillating sequence yung term. Tapos, alam ko naman pag series, alternating series. Kasi nga, nangyari negative 1, 1, negative 1, 1, negative 1. Ganun yung nangyari. Pero, hindi ako sure sa oscillating na term. Pero, ito nga, itong sequence na to, kung napapansin mo, yung sequence na, yung number niya sa loob, yung mga term na sa loob is naglalaro lang sa dalawang value, which is 1 and negative 1. Unlike naman dito sa una, yung values niya is start lang lagi sa 1. Ang values naman niya is palit ng paliit. Ang values naman niya is, hindi ako sure kung palit ng palit ba yung 4th root of 4, 5th root of 5. Hindi ako ganun ka-sure Pero, check na lang natin lately pag kailangan natin gawin. Okay? So, ganyan lang So, ulitin ko lang. What is b sub 3? Kunyari, what is b sub 3? Sir, b sub 3 is negative 1 raised to 3, which is equal to negative 1. Okay, so ganun naman maghanap ng terms ng ating sequence. Okay, so let's have number 5. So let's have c sub n. C sub n is defined to be cosine n pi over 3. So dito, pwede ulit tayo mag-start sa 0. Bakit? May cosine 0 kasi. Okay, kasi 0 times pi over 3 is 0. So cosine 0 nag-exist. Okay, so pwede kong gawin yun. So assuming ginawa kong ganito. So c sub n. Okay, c sub n is equal to, for n is equal to 0, cosine 0 is 1. Tama? For n is equal to 0, cosine 0 is 1. Next, we have cosine, for n is equal to 1, that is cosine pi over 3. Pi over 3, what is pi over 3? Pi over 3 is 60. So 60 degree, that is 1 half. Okay, for n is equal to 2, that is 2 pi over 3. 2 pi over 3. Okay, so check ko lang, 2 over 3 times, so 120. So tama ko 120. So cosine 120 degree is negative 1 half. Next, for n is equal to 3, so that is 3 pi over 3 is pi. So cosine pi is negative 1. Okay. Next, for n is equal to 4 na yan. So 5. So that is 5 pi over 3. 4 no. So for n is equal to 3, that is negative 1. For n is equal to 4, sorry. So that is 4 over 3 times 180. Okay, so 240. So what is cosine 240? Check ko lang Cosine 240 is negative 1 na ulit. Okay, next is for n is equal to 5, that is 5 over 3. Okay, so times ko lang sa 180. So that's cosine 300. So what is cosine 300? So cosine 300 is 1 half. Okay, so tuloy ko lang konti. So for n is equal to 5 na yan, so 6. So that is 2 pi. So cosine 2 pi is similar sa cosine 0 degree. So isang revolution na kasi. So meaning babalik to sa 1. Okay, and that so forth. Okay, kung napansin mo, from 1, babalik sa 1 half, negative 1, negative 1, negative 1 half, negative 1, negative 1 half, 1 half, 1, pabalik siya. Okay, so periodic, umiikot. Kung papansin mo sa values niya. Okay, so itong sequence na to, hindi natin muna pwedeng i-observe yung kanyang flow ng term kasi hindi ko pa ma-generalize talaga kasi hindi ko pa dinidiscuss yung convergence. Okay, so for the meantime, ang goal ko talaga dito is ma-determine mo paano natin nilalagyan ng laman yung sequence. So, paano mo sinusolve yung A sub 1, A sub 2, S sub 1, S sub 2, S sub 3. So, ang notation ko lagi is S sub n dito sa ating topic. So, usually sa ibang book, ang notation is A sub n. Okay, so let's have definition. A sequence is said to be bounded if there exists m, element ng real number, such that yung absolute ng S sub n is less than or equal sa m for all n element ng natural number. So, ito lang, konting illustration lang about dyan. Paano natin masasabi yan? Saka magagamit natin later on itong definition na to. So, assuming ito yung ating real number line. Okay? So, since yan yung real number line, assuming ito yung real number line, ito yung x-axis. Okay, so assuming meron dito number m. So, dito yung negative m niya. Okay, so kunyari, yung number m na yan, pinapalibutan lang niya yung mga sequence dito. So, assuming yung sequence pa ganyan-ganyan siya, kung saan napupunta. Okay, so ayun naman yung ibig sabihin yan. So, a sequence is said to be bounded if there exists m element ng natural number such that yung sequence, yung pinakamalaking s sub n, kunyari, nakuha ko dito, s sub 4, siya yung 1,000. Merong m, 1,001. Okay, so, meron mag-i-exist lagi na m na mas mataas sa kanya. So, masasabi mo siya na bounded. So, another thing dito rin, syempre, kung bounded siya sa m, bounded din siya sa negative m. Okay, so very useful to mamaya. Magagamit ko dun sa mga ibang proving. So, for example, inassume ko yung S sub n. So, since convergence, pwede kong sabihin na siya ay bounded. Then, pwede kong sabihin na may mag-exist na m such that ganyan yung property. Okay, so mamaya makakita nyo kung paano ko gamitin yung mga ganyang term. So, tandaan lang yan ha. So, definition, sequence is said to be bounded if there exists m element ng real number such that yung modulus o yung absolute value ng S sub n is less than or equal to m. Yung S sub n na yon, yung may so S sub n na yun sa lahat ng S, sa lahat ng term ng sequence sa loob. So meaning, kung sino man yung pinakamalaki dyan, may mas malaki pa rin na m dyan. Okay? So lahat sila bounded dun sa m. Okay? So next, let's have definition, another definition. So ito na yung importante dito. So a sequence S sub n of real numbers is said to converge to real number s provided that for each epsilon there exists a number n such that n is greater than 0 implies s sub n minus s is less than epsilon. So ulitin ko lang. So pag sinabi kong converge, ito natin lalagay. So convergent, s sub n converge to s, or another term, yung limit ng s sub n natin is equal to s. This is if and only if. So, yung dalawa na yan, ito lang ibig sabihin. For every epsilon, so for every epsilon greater than 0, there exists n such that n is greater than big N natin, implies s sub n minus s is less than epsilon. Okay, so ayan lang yung ating definition na gagamitin. So parang, sir, para siyang epsilon delta. Since wala tayong delta na ginagamit, so para lang siyang epsilon definition. Okay, so may other akong napanood kasi na nagdi-discuss about epsilon. Ang basa nila sa epsilon is epsilon. Nagulat din ako. So, maaaring tama kasi epsilon. So, pero sa atin, epsilon na lang. Kasi Pilipino naman yung natin, yung slang natin. So, ulitin ko lang ha. Ayun yung definition ng sequence ng ating, yun yung definition ng limit ng ating sequence. Okay, so tuloy tayo dun sa ating next topic about dito. Okay, so let's have notation. So ayun na nga, nasulat ko na pala kanina, no? So yung the sequence S sub n approaches to S, or the limit of S sub n is equal to S. So ibig sabihin na to as n approaches infinity ha. So ibig sabihin lagi may naka-attach dyan na n approaches infinity. Okay, so hindi ko na nilalagay kasi sequence naman pinag-uusapan eh. So based sa definition ng sequence, siya ay approaches infinity. Kahit ito, hindi ko nilalagay kung napapansin. Okay, so yan yung usual notation natin. Okay, so kunyari, alam mo yung value nung limit nung ano natin, yung sequence natin, so ilalagay mo lang ganyan notation. It's either ito or yan. Okay, so for example, yung sequence nung 1, okay, kung napapansin mo, ano yung mga sequence nung, ano yung mga term nung sequence ng 1. Sequence ng 1 is 1, 1, 1, 1, 1, 1, 1, and so forth. So, obviously, ito ay approaches to 1. Or, pwede kong lagay na ganito, or limit ng 1 is equal to 1. Kasi siya yun eh. Okay? So, pag ganyan, pag may nag-exist ang limit, therefore, 1 is convergent. Yung sequence natin na 1 is convergent. Or converge to 1. Okay, so yan yung terminologies natin about dyan. Okay, next, tingnan si number 2. Observe natin yung behavior. So, since pwede siya sa 0, ano ba yung mga laman nito? Ang laman nito, 0, 1, negative 1, 1, negative 1. So, alternating to, no? Kung napansin nyo, ang laman kasi nito, sir, 1, negative 1, 1, negative 1, and so forth, salitan lang. Kung napapansin mo, saan siya nagko-converge? Sir, nagko-converge po siya sa dalawang number, 1 saka negative 1. So ngayon, ito pa yung isang special dito. Ang limit ng sequence ay iisa, katulad dun sa limit ng function. Sa limit ng function, isa lang siya. So dito, ang limit ng sequence, isa lang din siya. Okay, so since nagko-converge siya sa more than 2 numbers, therefore, hindi siya convergent. Okay, so hindi ko pwedeng sabihin converge. So hindi ko pwedeng sabihin hindi ko pwedeng ilagay notation na ganyan. Na approaches 1 and negative 1 siya. Hindi pwede yun. Okay, so lalagay ko lang the sequence of negative 1 raised to n is divergent. Okay, so ganun siya. Simple. Next, ito naman sequence ng 1 over n. As n approaches infinity, so start tayo sa 1 ha. So 1 over 1 is 1, 1 over 2, 1, for n is equal to 2, that is 1 half. For n is equal to 3, that is 1 third. For n is equal to 4, that is 1 fourth. So kung napapansin mo, paliit siya ng paliit. So, habang lumalaki yung n, approaching siya sa 0. So, this is converging to 0. Okay, so, yung 1 over n, yung sequence na 1 over n is convergent. Siya ay convergent sequence. Okay, next, yung n. So, kung napapansin mo sa n is for n is equal to 0, that is 0. For n is equal to 1, that is 1. For n is equal to 2, that is 2. So, kung lagay ko lang ha, ang laman nito is 0, 1, 2, 3, 4, up to infinity. Tama, kasi infinity naman yung todo lahat nandito. So, ngayon, sir, pwede ko ba mako-consider na number sa infinity? Sabi ko nga sa inyo from the very beginning, sa theory pa lang, si infinity hindi siya number. Hindi pa natin siya i-consider na number hanggat hindi ka nagre-real analysis. So, since hindi siya number, so siya ay parang representation na kung saan number na nasa dulo. So, madami silang number na nasa dulo. So, tuloy-tuloy, yun kasi yung ibig sabihin yan. So, meaning, anong ibig sabihin nito? Yung n nagko-converge sa madaming number actually. From 0, 1, 2, 3, up to infinity. Doon siya nagbabago eh. Okay, so therefore, since nagko-converge sa madaming number, so hindi ko siya literal pwedeng sabihin na convergent. Siya ay divergent. So, si sequence na n is divergent. Okay, so next is number 5. That is the sequence na negative 1 raised to n times n. So, ito medyo kakaiba, no? So, for n is equal to 1, that is positive 1. Tama? For n is equal to 1, for n is equal to 0, try natin start sa 0. Ang unang laman nito is 0. Okay, for n is equal to 1, that is negative 1. For n is equal to 2, that is positive 2. Sunod, negative 3. Sunod, positive 4. Sunod, negative 5. So, kung napapansin mo, sir, saan siya papunta? Papunta siya sa dalawa. It's either papunta sa negative infinity or papunta sa positive infinity. So, kahit nga lang isa dun eh. So, papunta siya sa positive infinity, assuming pumunta siya sa positive infinity. Alam natin, siya ay divergent pa rin. Pumunta siya sa negative infinity, alam natin, divergent pa rin siya. So, lagay ko na lang. So, yung sequence na negative 1 raised to n times n is divergent. Okay? So, ganyan lang siya kasimple pag nagsasabi tayo kung divergent o convergent. So, hindi lahat ng sequence pwede mo sabihin agad convergent, divergent eh. Okay? Although, madali talagang hulaan dito kung divergent o convergent siya. Ngayon, ang concern natin, paano naman siya i-prove? Okay? Kasi ginawa natin sa limit of a function eh. So, limit of a function using epsilon delta definition, na-prove natin na yung limit ng isang function nag-e-exist. Tama? So, dito ganun din. Paano natin ipoprove na yung limit ng isang sequence is nag-exist? Tulad nito, a discussion about proof. Number 1, prove that the limit of 1 over n squared is equal to 0. So, aware tayo, yung limit ng 1 over n squared o yung sequence na 1 over n squared approaches sa 0 yan. Aware tayo dyan. Ngayon, iprove natin na yan ay 0. Okay, so ganito natin siya ipoprove. So, normally dati ang ginagawa natin, proof agad, let epsilon be given, then something blah blah blah. Ngayon, iibahin ko konti yung way natin since limit naman yung pinag-uusapan. Kasi dito, may mga nag-i-exist na upper bound, lower bound. So, kailangan muna natin ng term na tinatawag na discussion. So, pag nilagay itong word ng discussion, meaning, discussion, dito natin i-analyze anong klaseng n. Kasi larger n yung hinahanap natin dito eh. So, i-assume natin epsilon greater than 0. So, maghahanap tayo ng malaking n such that yung n na yun, pag sinubstitute ko, masasatisfy yung condition natin. Okay? O yung conclusion ng ating sequence, yung limit ng sequence. So, ngayon, ito yung discussion na gagawin natin. So, discussion, hindi pa siya yung proof, yung formal proof. So, hindi ko sure kung ano. So, in this discussion, our task is to consider an epsilon greater than 0. So, consider epsilon greater than 0 and find. So, maghahanap tayo ng n. Find n, element ng natural number. Ngayon, yung n na yan ay will depend on epsilon. So, meaning, yung n na yan equal sa epsilon something or 1 over something epsilon. So, dapat yung n na yan equal sa something na may epsilon. Good dyan. So, ulit for every epsilon greater than 0, find n element ng natural number such that, so sabi na such that n is greater than n. Yung small n is greater than n. So, ang goal natin, maghahanap lang tayo ng n na yan. Okay? Implies, so based sa definition, implies S sub n, what is S sub n? S sub n is 1 over n squared minus 0, ito yung ating limit, is less than epsilon. So, yan yung goal natin. So, n yung discussion. Ganyan ko umpisahan. So, consider natin epsilon greater than 0. So, maghahanap tayo ng n, element ng natural number, such that small n is greater than larger n, implies 1 over n squared minus 0 is less than epsilon. So, ngayon, consider natin to, yung part na to. So, we all know na itong part na to, yung 1 over n squared minus 0 is less than epsilon. Ang mangyari dyan is ganito. 1 over n squared is less than epsilon. So, pwede natin i-drop dyan yung ating absolute value. Kasi nga, positive number din naman yung n na yan eh. So, ang mangyari dito, this implies, okay, that this is 1 over n squared less than epsilon. Tama. Next is i-manipulate natin siya. Ang gagawin natin, dapat epsilon yung matira. Okay, so ang gagawin ko, this is 1 over epsilon. This implies, this is 1 over epsilon less than n squared. Tama? So, cross multiply ko lang. Next is square ko lang both sides. So, pag in-square ko both sides, this implies na that is 1 over square root of epsilon is greater than, is less than n. Ganun yung nangyari. Ngayon, ano yung gagawin natin dyan sa value na yan? Tama? So, anong gagawin natin value? Ngayon, anong nangyari? Yung n is greater than 1 over epsilon. 1 over square root of epsilon. So, we can choose. Hindi ko nakikita. We can choose n to be 1 over square root of epsilon. Okay, so ayan yung pwede kong piliin. So ngayon, punta na tayo doon sa formal proof. Okay, so this is the formal proof. So dito talaga mag-start yung proving. So ganun ulit, let epsilon be given. So let epsilon be greater than 0. So ngayon, choose n is equal to 1 over square root of epsilon such that n is greater than n. Tama? So we choose n is equal to 1 over square root of epsilon such that there exists n. Kaya ka lang, such that there exists n such that n is greater than n. So this implies, ano mangyari? So ano yung n? Yung n is 1 over epsilon. So this implies that n is greater than 1 over square root of epsilon. Okay, so anong gagawin natin dito sa formal proof? Kung napapansin nyo, sa formal proof, i-reverse natin yung process, pabalik doon. Okay, so from here, pupunta tayo dyan, papunta doon, hanggang doon. Okay, ayun yung hahabulin natin. Okay, so for n is greater than 1 over epsilon, ano mangyari? I-square ko both sides. So this implies that this is n squared is greater than 1 over epsilon. Okay, then multiply natin konti. This implies that epsilon, dito ko nang lalagay, this implies that epsilon is greater than, magiging greater than 1 over n squared. Okay, so ayun, nangyari na napunta na ako dito. Okay, since ganito na lang, thus for n is greater than n. Okay, so for n is greater than n, we have 1 over n squared minus 0 is less than epsilon. And we are done. So, ulitin ko lang. So, anong nangyari? Nung nag-formal proof na tayo, let epsilon be given, choose n is equal to 1 over epsilon, 1 over square root of epsilon, so such that there exists n is greater, small n is greater than n, then ito yung ginamit. So, mula dun sa property na to, pinalitan ko yung n ng 1 over square root of epsilon. So, anong goal? Ang goal, mula dito, balik natin papunta dun. Nung nabalik na natin papunta dyan, kailangan mapunta na tayo dito. Okay, so this is implies, lagay mo dito yung word na implies. Okay, dyan. Okay, so ganyan yung mangyari. Ayun lang yung kulang ni sir. So therefore, ganyan mag-prove ng limit ng sequence. So sir, lagi po ba kami maglalagay ng discussion? Yes, mas mabuti na yung lagay ka ng discussion. Yung terming ko is discussion para mapag-usapan mo o ano yung magde-decide ka, ano ba yung dapat mong gamitin about dyan. Okay, so ganyan lagi yung ating rule. Yung way ng pag-prove ng limit ng sequence. Okay, so next is number 2. Prove that the limit of 3n plus 1 over 7n minus 4 is equal to 3 over 7. Okay, so similar ulit, ganun gagawin natin. No? So discussion, let epsilon be greater than 0. Okay, so let epsilon sa discussion, lagay ko lang dito. Hindi ako sure kung tama spelling ng discussion ko. Okay, so consider epsilon greater than 0, and we will find n, big N, element ng natural number such that yung n is greater than n, small n is greater than n implies yung 3n plus 1 over 7n minus 4 minus 3 over 7 is less than epsilon. Okay, so ayan yung gagawin natin. So ngayon, etong part na to, yan yung i-manipulate natin. So ang goal natin, dapat ang matira sa isang side is n lang. Kasi ayun naman yung ginagawa ko, kung napansin nyo. Okay, so consider natin to, simplify natin further. So pag nag-simplify tayo, that is simply 21 yun. So pag sinimplify ko siya, 3n plus 1 times 7, that is 21n plus 7. 3 times 7 ay minus 4, so that is minus 21n din. Tama? And then plus 12. All over 7 times 7n minus 4 less than epsilon. Okay, so kung simplify pa natin further yan, that is equivalent sa so ano equivalent na sa taas? Ang equivalent ng sa taas is 7 plus 12, which is 19. Tama. So drop ko na rin yung ating absolute value So ulitin ko lang, idadrop ko yung absolute value, 21n minus 21n is 0, 7 plus 12 is 19. So mangyari ito ay 19 over 7 times 7n minus 4. Okay, less than epsilon. Okay, so ngayon i-manipulate ko. Yung epsilon dadaling ko dito, yung 7n minus 4 dadaling ko doon. Ulitin ko lang yung 7n minus 4 dadaling ko doon. Okay, ngayon kung nagtatanong, sir, baka po mag-0, never mag-0 yan. Kasi kunyari, for n is equal to 0, kasi ang n nag-i-start lang sa 0, 1, 2, 3. Ngayon, kung dineclare natin siya natural number, mag-i-start sa 1. So, lagi yung positive. Tama? So, that is 3, then 10. So, yun yung mga minimum values niyan. So, ang gagawin ko ulit si epsilon mo multiply ko dito, sa 7n minus 4 mapupunta doon. So, this implies, this is 19 over 7 epsilon less than 7n minus 4. So, ang goal natin, matira yung n sa isang side. So, transpose ko tong 4 na to. So, this implies that 19 over 7 epsilon plus 4 is less than 7n. Okay, next is divide both side by 7. So, pag dinivide ko to by 7, magiging 49 sa ilalim. Ito magiging 4 over 7. Kung tama ako ng pagkakasolve. Okay, so this implies that 19 over 49 epsilon plus 4 over 7 is less than n. So, nakahanap ako ng small n. Okay, so we can choose. So, dito ko nalagay. So, we can choose n to be 19 over 49 epsilon plus 4 over 7. Okay, so yan yung gagamitin na natin na values ng n. So, proceed na tayo sa formal proof. So, here's the formal proof. So, formal proof. Okay, so for formal proof, let epsilon greater than 0. So, choose n. So, choose n to be 19 over 49 epsilon plus 4 over 7. Okay? So, ngayon, thus, lagay ka na lang, thus, there exists n, lagay ka na lang to, there exists n such that n is greater than or equal to n implies yung ating conclusion. Kasi yun nga hanapin natin. Pero, since hindi pa natin nagagawa, hindi ko muna gagamitin. Okay, so ulit there exists n such that n is greater than n. So, consider natin itong part na to. So, this is equal sa n is greater than 19 over 49 epsilon plus 4 over 7. Okay, so ngayon, i-manipulate natin ng konti. Paano yan babalik? Ang mangyari dyan, that is 7n minus 4. Tama, so ganun yung gagawin ko. So, manipulate ko muna, multiply ko muna yung 7 dito. So, this is 7n. So, this implies that 7n is greater than 19 over 7 epsilon plus 4. Okay? Which implies that 7n minus 4 is greater than 19 over 7 epsilon. Okay, then, anong gagawin? Ititira natin yung epsilon dito sa side na to. So, dadalhin natin doon. So, this implies na ang values niya would be epsilon yung matitira dito, no? So, this is epsilon is greater than 19 over 7 times 7n minus 4. Okay, so kung check nyo nakabalik na ba tayo doon? So kung napansin nyo, nung ginawa ko, bumalik na tayo dito. Since nakabalik tayo dyan, pwede na natin gamitin yung conclusion. So, or thus, there exists n element ng natural number such that n is greater than n implies yung conclusion, lagay natin, implies yung 3n plus 1 over 7n minus 4 minus 3 over 7 is less than epsilon. And this is Done. So, kung napansin mo, pagkabalik ko nito, ito na ako. Thus, there exists an element of natural number such that n is greater than big N implies, ito na. Okay, so ito yung nilalagay ko sa huli. Okay, so ganyan mag-prove ng epsilon definition dun sa ating limit ng sequence. So, let's have another example. Paano naman pag may n squared na involved? Okay, so let's have number 3. So, ito medyo tricky kasi kanina, prove that the limit of 4n cubed, okay, so that is 4n cubed plus 3n over n cubed is equal to 4. So, tama yung given ko. Okay, so, ano yung gagawin natin? So, una, discussion ulit. Tapos ngayon dito medyo may kakaiba akong gagawin. So, hoping na magets mo yung gagawin ko. So, yung gagawin ko dito, pag na-encounter mo yun, gagawin mo rin. Nadaan nyo lang ha. So, for example, discussion natin. So, discussion. So, let's have discussion. Okay, so let epsilon. So, consider epsilon greater than 0. So, and find n element ng natural number such that n is greater than that big N implies yung 4n cubed plus 3n over n cubed minus 6 minus 4 is less than epsilon. Okay? So, ito medyo mahaba yung mga mangyayari. So, hoping na maintindihan mo rin. Okay, so ngayon, check natin. So, consider itong part na to pag sinimplify. That is cross-multiply doon. So, this is simply 4n cubed plus 3n minus 4n cubed, okay, plus 24 all over, so nag-fraction lang ako dyan ha, n cubed minus 6 less than epsilon. Okay, so yung pinaka-simplify nyan, so this implies that this is 3n plus 24, tama? So that is 3n plus 24 over n cubed minus 6 is less than epsilon. Okay, so ngayon, ito yung mga magiging concern, sir. Kung napansin mo, ito yung problema. Okay, so ngayon, maghahanap tayo ng upward ng kanyang bound. So, kunyari, sure ako na ito ay bounded. May mas malaki siya konti sa constant times n, diba? Ito n over n cubed. So ngayon, sure ako na itong part na to, lagay ko lang dito sa taas or somewhere sa ating, hanap ako ng ating pwedeng anuhin. Sure ako itong part na to, yung 3n plus 24 over n cubed plus 24. So dito lang ha. So yung 3n plus 24 over n cubed minus 6 is bounded siya dito sa some constant multiplied by yung pinakamalaking exponent sa taas is n, that is n raised to 1, then n cubed, or k times 1 over n squared. So, ayun yung hanapin natin. So, 1 over n squared something. Then, dyan dapat siya bounded. So, ulitin ko lang. Ito ay parang highlight lang nung hahanapin natin. Okay, ngayon. Para makahanap tayo ng ganyang bound, so, ang gagawin natin, hahanap ka ng upper bound ng numerator tapos lower bound ng denominator. Ulitin ko lang, hahanap ka ng upper bound ng numerator tapos lower bound ng denominator. Lagi. Okay, so consider for the numerator. So for the numerator, 3n plus 24. Okay, so ngayon, ang naiisip ko na upper bound na mas mataas sa kanya, saan nanggagaling si n? Nanggagaling si n kay 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something. Kasi natural number sa n eh. Okay? So, ibig sabihin, pag sinet ko to na 1, that is 3 times 1 plus 24, 27. So, ibig sabihin, yung pinakamaliit na, yung parang, yung pinaka-supremum na malapit sa kanya is si 27. Pero gagawin ko, 27n. Okay? So, ulitin ko lang ha. Pinakamalapit ko, 3 times 1 plus 24, that is 27. So, nag-attach lang ako ng n para sure ako na mas mataas siya. So, sure ako, kunwari, 4n is equal to 1, mas mataas, equal sila. 4n is equal to 2, mas mataas na to dito. Okay, ganun yung nangyari. So, nakahanap ako ng upper bound. So this implies na pwede kong sabihin na 27 n over n cube minus 6 is less than epsilon pa rin. Okay, so nakahanap ako sa numerator. Ngayon, pagdating sa denominator, hahanap naman ako ng lower bound. Okay, so meaning bababaan ko naman. So, hanap naman ako ng pinakamababa sa kanya. So, for the denominator, so the denominator is n cube minus 6. Okay, so saan siya mas mataas? So, kung papansin mo, sir, mas mataas po siya. So, hindi ko pwedeng sabihin na mas mataas or greater than or equal siya lang kay n cube. Hindi ko pwedeng sabihin. Kasi, kung pansinin mo, for n is equal to 1, mas maliit to. Which is not true. Ngayon, sure ako na mas mataas siya. What if ang gawin ko, i-multiply ko to something sa fraction. So, kunyari, sa 1/3, so 1/2, 1/4. So, kung observe nyo itong gagawin ko, kunyari, minultiply ko sa ganyan. So, n cube times 1/2. So, for n is equal to 1, or for n is equal to, so ngayon, hindi pa natin alam kung saan kailan magiging true to. Tama. So, ito pa yung problema. Sir, n is net mo. Pero hindi pa natin sure kailan yan magiging true. So, magiging true yan pag minanipulate natin. So, tayo natin i-manipulate. So, 2 times n cube, that is 2n cube. Tama. 2n cube minus n cube is n cube. Okay, ulit ha. 2 times n cube, 2n cube. Minus n cube dito, kasi tatranspose ko sa kabila. That is n cube na lang. Ngayon, 2 times negative 6 is negative 12. Itatranspose ko sa kabila, magiging positive 12. So, this is greater than or equal to 12. Ngayon, nahanapin natin yung value na n na kung saan true to. Okay, so, pag n cube, pag cube root natin yung 12, so, note that yung cube root, that is yung cube root ng 12 is, ang sabi, ang cube root ng 12 daw is 2.289. So, ibig sabihin, true to for n greater than 2. Okay, so magiging true yan for n greater than 2. So, meaning, assume na natin na tama to. So, this implies, so it is a pieces to show that 27 over n over, gamitin ko na tong n cube, yung ating lower bound, n cube over 2 is less than epsilon. Okay, from there, dyan tayo mag-work. So, ayun yung gagamitin natin na n. So, hanapin natin ang value na n. So, pag sinimplify ko further, that is 57n. Tama, no? That is 54, sorry. That is 54 n over n cube less than epsilon. Okay, so din yung nakita. Okay, next is, this implies that is 54 over n squared less than epsilon. So, we need to solve for n. So, this implies n mapupunta doon. So, this is 54 over epsilon is less than n squared. So, which implies na si square root of 54 over epsilon is less than n. Okay, so we can choose. So, we can choose that n to be pwede natin i-choose si n na ngayon, dalawa yung values, magiging values ni n. Okay, so hindi ko basta-basta pwede sabihin na ito yung value ng n. Tama, kasi ang value na n dito is square root ng 54 over epsilon. Ngayon, dalawa kasi mangyayari. Yung unang value na lumabas is n is greater than 2. Pangalawang value is n is greater than square root of 54. So, we can choose yung maximum between sa kanilang dalawa. Sino yung mas malaki? So, yung maximum between 2 and square root ng 54 over epsilon. So, ulitin ko. Bakit dalawa yung ginamit ni sir sa pag-choose ng n? Kasi anong nangyari, may lumabas akong value ng n. Yung lower bound. Yung pinakamalit na values na n na gagamitin natin. So, between sa kanya, saka doon, pipiliin natin yung maliit. Although, ito yung kukunin ko. Okay? So, ngayon, we can proceed na doon sa ating formal proving. So, pwede natin i-choose. Okay? So, pwede natin i-choose itong part na to. Okay? So, let epsilon greater than 0. So, ito na yung formal proof. Okay, so let epsilon greater than 0 and n be equal sa maximum between 2 and square root ng 54 over epsilon. So, ngayon, anong gagawin? Thus, there exists n such that n is greater than n. So, hinahanap natin yung implies. So, syempre, ang pipiliin natin na n dyan is ito. Ito kasi yung babalik talaga mula sa umpisa. Okay? So, between sa kanin dalawa, mas maliit talaga to. Okay? So, consider natin si n greater than n. And this implies that n is greater than square root ng 54 over epsilon. Okay? So, pag revert back ko, that is, this implies that n squared is greater than 54 over epsilon, or simply that is epsilon, epsilon greater than 54 over n squared. So, meaning, bumalik na ako dito. Okay, so hindi ka pa bumabalik dito. Okay na ako dito kasi nga, gumamit ako ng mga upper bound saka lower bound. So, since nakabalik na ako dito, pwede ko nang i-assume yun, o pwede ko nang i-conclude. Okay, so thus, for every epsilon, for every n element ng natural number such that n is greater than n, okay, implies, lalagay ko lang yun, itong part na sa taas na to, okay, implies that 4n cube plus 3n over n cube minus 6 minus 4 is less than epsilon, and that is done. Okay, so dito medyo crucial. So tandaan nyo sa paghanap sa numerator, may encounter mo lagi yung ganito. Okay, so mga problem sets, ganyan yung mangyayari. So check mo yung gantong lalabas. Kunwari, nakita mo n over n squared, hahanap ka naman ng k times 1 over n. Tapos magbabago dito syempre. Okay, hindi lang basta n, di n cube dito, n squared. So lagi sa numerator is upper bound, sa denominator is lower bound. So ang ginagawa kasi natin is pinapalaki natin. Okay, so ang bounded siya dapat. So kunyari, pag the more na pinapalaki mo yung numerator, the more na pinapalit mo yung denominator, the more na lumalaki yung buong fraction. Okay, so ang hinahanap kasi natin yung k times something, yung upper bound niya, yung mas mataas sa kanya konti. Okay, so hoping na nagets mo kung paano mag-prove ng limit ng function, ang limit ng mga sequence. So medyo tricky siya talaga totally. Pero at least na-discuss ko siya ng maayos, or at the same time, napakita ko yung mga technique or something na gagamitin natin. Okay, so hoping na sunod ka dun sa next video natin, which is limit theorem for sequences.